Hi, Mr. Bouchard here, and welcome to Science 8. And today we're going to be talking about how do scientists solve problems. So first, just a little do now to think about. Describe what happens when you get bitten by a mosquito. All right, so just think about that for a moment. Well, you know the big answer. You get a bite like that, all right? And sometimes it welts up, depending on who you are. My wife gets filled with them. She gets bitten like crazy, but it can be annoying. So we're going to use this as our problem for today. So let's take a look at the steps of the scientific method. So how do we use the scientific method in our life? Which we actually do. We don't even realize it on a regular basis. So let's take a look at that. And here's actually a scenario. And this was actually a Yankee game years ago, and that's the pitcher Jabba Chamberlain, and he got swarmed by bugs, and the umpires tried to spray him with off, right? And that was their way of solving the problem, right? Trying to use bug spray. Unfortunately, it didn't work too well. The bugs kind of just hung around, and it was really annoying to both pitchers. I think for both teams for a little bit. But either way, they're using the scientific method. So let's apply that to this. All right, so first step is always to state a problem. So state the problem. In this case, the best way to do so is asking a question. So question or a problem you're trying to solve, but writing a question does it right away. All right, states the problem. So does bug spray prevent mosquito bites? That would be my question for that experiment. Okay, hypothesis. So after you design your experiment or ask the question, you have to have a possible solution. That's what the hypothesis is. Does it have to be correct? Nope. All right, and that's what an experiment is all about. So it must be testable though. So it has to be realistic. You can't just kind of like throw a random thing out there that you won't be able to test. Sometimes the best way to frame it is using an if-then statement. If I change this in the experiment, then this will happen. And that makes a proper hypothesis because you're telling what you're changing in the experiment and you're giving a possible end result. And that's what you need for a proper hypothesis. So an example, if bug spray is applied, then mosquito bites will be prevented. So that's a well done hypothesis statement. All right, because you're telling what you're changing, so use bug spray, and you're telling what's the end result should be. Mosquito bites will be prevented. So that's an up close version of it, and you can see the proboscis that's coming out of this mosquito. That's actually what bites you. So they put that into your skin. You don't really feel it, but that's how they give the saliva to your skin, and that's how you end up getting that bite. All right, so how do we test the hypothesis? Design the controlled experiment. All right, so that's going to be our next thing. And controlled experiment doesn't mean that the experiment is not going to run out of control. What it means, you have to have something to compare against. All right, and I'm going to get to that in a moment. So the first variable in the experiment is called the independent variable. This is the manipulated variable and what's being tested or changed in the experiment. All right, so you got to think about that one. Which one is it? So we'll come back to that with the bug spray example in the moment. So only test one independent variable per experiment, because the problem is if you do two at a time, you don't know what actually did the change in the experiment. So you have to make sure you do only one at a time, and then if you want to experiment further, run another experiment with another variable. Dependent variable is a responding variable. That's what's being measured in the experiment. And again, where they go on your graph is actually going to be a thing when we talk about graphing in the future. So make sure you take note of that. And controls are the parts of the experiment that remain the same. You're going to say, what? those are the things that we want to keep constant in the experiment. So for instance, we set up a plant growth experiment. We don't want to set that up in multiple places, all right? We don't want to have one plant in one area, one plant in another area. We want to have similar conditions to those plants. So we put them in the same place where they get similar temperature, similar sunlight, things like that. All right, so controls are a way to keep your experiment consistent, basically. All right, and sometimes we don't think of them right away. They take time for us to actually figure them out, but we have to try to keep our experimentation consistent. All right, and then control group, don't get that mixed up. That's the group of people that will not get the experimental condition. They get the conditions kept the same. So in other words, for the bug spray experiment, they would be the people that don't get bug spray. Oh, those sorry people. So there'll be a group with the bug spray, and then there'll be a group without the bug spray. And the control group is the group without the bug spray. And why are they there? Well, they're there for comparison, right? You need to see if the stuff works in the end of the experiment, right? So the only way you can do that is having a group that doesn't get the experimental condition. And that's what the control group is about. The experimental group receives what's being tested, the independent variable, and then you run your experiment. All right, so if bug spray is applied, then mosquito bites will be prevented. So what is the independent variable in that experiment? Well, the amount of bug spray applied. All right, so I'll write that up front. So amount of bug spray applied. Okay, and the next thing, so what is the dependent variable? All right, the dependent variable is what I'm measuring. So in the case of this, well, we're going to count the number of bites. So number of bug bites. Okay, which group will get the bug spray? All right, they're the group called the experimental group. All right, and the ones that don't get the bug spray would be called the control group. All right, so in general, make sure you know the difference between those two groups. Make sure you understand the whole idea of the independent and dependent variable, which we're going to do some assignments practicing that. All right, so I'll give you scenarios and you'll have to read them and be able to figure out what's independent. Again, that's the one you change. Dependent variable is the one you're measuring in the experiment. Okay, then we get our data. And then what? Well, we got to start organizing it. We don't want to just have random scattered data. So what we do, we obviously can make data tables, all right? But we can also make charts, graphs in different ways to try to make it easier for your audience to read. A lot of times in meetings, it doesn't even matter if it's science. It could be a business meeting. A lot of people will show graphs because showing it in a picture will make more sense to people that are listening. So it could be a line graph, a bar graph, a histogram, a pie chart. This is a pictogram. So there's different ways to represent your data. And just organizing it is the key here. And then lastly, after you get your data plotted, then you want to explain it. So you state if the hypothesis was supported. So in the end, bug spray prevents mosquito bites, so I will wear bug spray. All right, so basically you're concluding your experiment. Okay, so keep those mosquitoes away. I think that's in Australian. Mozzie, because that's what they call the mosquitoes. All right, and the experiment doesn't end there, right? If you run an experiment once, the problem with it is accuracy, precision. So we have to repeat the experiment to make it more reliable, more accurate. The more times you do it, obviously, the better data you're going to get. Another thing we could do the second time we run it we could increase our amount of people doing the experiment. If we do this, then we get more data and again, better results. All right, and that's what we're looking for here. Can we repeat the experiment? Does it work every time? And is it consistent? And that's it. Thank you guys for tuning in. But that's the notes on scientific method.